13-4, compound probabilities. A compound probability is a probability of A and B. If A and B are independent events, the probability of A and B is how it's going to be written. And what you do is you set probability of A times probability of B. To be an independent event, it is when the occurrence of an event does not affect how the other event occurs. If it is dependent, the occurrence of the event does affect the occurrence of another. So as examples of that, if we toss a coin and a dice, those are independent. Tossing the coin and tossing the dice does not affect each other. But if we draw a marble from a bag and without returning it or replacing it, draw another marble from the bag, drawing that first one and not replacing it will change the number in the bag. So those are dependent. So if we're tossing that coin and a dice, and we want to find the probability of a heads and a 3, well, the probability of getting a heads when you toss a coin, you take probability of heads times the probability of the 3. And that probability of getting a heads is 1 out of 2, because you either have a heads or a tails. To get a 3, there's only one chance out of the 6 you'll get a 3. So you take and multiply those, and you multiply numerator straight across and denominator straight across, and you get 1/12. That is your chance of getting a heads and a 3. If we have the probability of mutually exclusive events, what that is the probability if A and B are mutually exclusive events, the probability of A times B equals 0. And the probability of A or B is equal to the probability of A plus the probability of B. So to be mutually exclusive events, they are events that cannot happen at the same time. So if we have a bag and it contains 15 chips, there are 2 green and 4 red. If we want to find the probability of a green or red chip, we have to find the probability of the green or the probability of plus the probability of the red. So the probability of green, there were 2 out of 15. Probability of the red is 4 out of the 15. Add them together and you get 6 out of 15. Make sure you always simplify your fractions. So again, 6 is 2 times 3. 15 is 5 times 3, so you get 2 out of 5 chance of getting a green or a red chip. If you have the probability of overlapping events, what that means is if A and B are overlapping events, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So it's written the same as the mutually exclusive, so you have to see if they overlap. And what overlapping events always have an outcome in common. And so when they overlap, you need to do the subtraction of that overlap. An example of that is a set of cards contains 4 suits, red, green, blue, and yellow. In each suit, there are cards numbered 1 through 10. These overlap because each suit has a 1 through 10. So there is the overlap there. So when we are solving this, and we are trying to find the probability of a green or red card, or a 1, we have to find the probability of the green or red, which was originally adding them together, and then the probability of the 1. So those are the 2 events that we're adding together. What we're subtracting off is the probability of having the green or red card and a 1. So when we're going through that, what I always do is do each event separately. So we have the probability of the green or red, which was 10 out of 40 for the green, 10 out of 40 for the red, so that makes 20 out of 40. We can leave it at that, or we can simplify down to the 1/2. The probability of the 1, well, in the 4 suits, there's a 1 in each suit, so that's 4 out of 40, which is 1/10. The probability of getting a green, red, or 1, well, in the greens, there's only 1 1, and in the reds, there's 1 1. So that's 2 out of the 40, or 1/20. So then we have to add those events together of the 1/2 plus 1/10, but that overlap of the 1s in the greens and the reds is what we would subtract off. So I left it simplified because then I can go back over that when you add fractions, you always need your common denominator. So to 1/2, I need to have 20ths, so I multiply top and bottom by 10, get 10 20ths. With 1/10, I'd multiply top and bottom by 2 and get 2 20ths, and then the 1/20th I would subtract off. So 10 20ths plus 2 20ths is 12 20ths minus the 1/20th, and I get 11 20ths. So that finishes off the concepts that are in this section 13-4. So now you will do the next 3 experiments and the problems on the next 3 pages of your packet.